Hi everyone, we are Group 10 and will present about Group Mini project for Dynamic. For our title is Kinematic of Rigid Bodies. First of all, my name is the leader, matrix number is CD190068. Now I will present about Introduction Kinematic of Rigid Bodies. Kinematic of rigid bodies involve both linear and angular quantities. In general, when a rigid body moves, both its position and orientation vary with time. In the kinematic sense, these changes are referred to as translation and rotation respectively. Properties of rigid body. Type, role of the rigid body in the simulation. Active object is directly controlled by simulation result. Passive object is directly controlled by animation system. Mass specifies the weight of object. Correlate mass automatically correlate mass value of object. For this mini project, we will analyze the motion of particle system and rigid bodies undergoing translation and rotation motion of pizza cutter wheel. The pizza cutter works by the wheel and axle rolling across the pizza, and the weight split the pizza in parts. The lever comes into play by applying force to the handle for the weight to cut the pizza. The axis of rotation is no longer fixed in space because the body is translating. We will describe the motion through a mass center translation and a rotation around the mass center. The next is objective of kinematic of rigid bodies. Understanding concept of kinematic of rigid body, identify the properties of rigid body motion, determine Newton's second law particularly and theoretically, identify the effect of acceleration, angular acceleration, string tension, and the moment of inertia of the wheel. That's all my present. Thank you for watching.
Methodology of pizza cutter wheel. The most common way is to use a wheel that rotates in a circle and move the cutter in a direction that they would like to cut the pizza. Many people may use the wheel pizza cutter to other things, including craft work. There's a scientific reason why so many pizza cutters are bad at their jobs. We can find out the appropriate design of pizza cutter wheel through the formula of here is the free body diagram of pizza cutter wheel. There are some forces that act on the cutter which are the weight of the cutter, force which pulling the cutter, and the force which come from pizza. Two equations are needed which are the Newton's second law and the rotational equation of Newton's second law. Now, we can calculate the kinetic energy of a rolling wheel. In rolling motion, W equal to Vc divided by shear stress. So the final equation will be like this. Another way of getting the kinetic energy is to use the fact that the wheel appears to be instantaneously pivot above the bottom. So K equal to 1/2 multiplied by IB W squared. IB is the moment of inertia of the wheel when rotated about an axis passing through the rim. IB equal to I plus N shear stress squared. Final equation will be like this. There are two types of pizza cutter. First is pizza wheel cutter and second is rocker knife cutter. Smart way to use pizza cutter wheel. Cut homemade pasta, slice marshmallow for hot chocolate, cut out flatbread, cut the crust of bread, slice out veggies, slice a sandwich, cut out biscuits dog, chop out spaghetti, and cut out pancakes.
Hi, my name is ZUWARI and I'm going to talk about calculation, analysis, evaluation. A pizza cutter has a driving force is at 45 degrees to the cutting board. The blade radius is 50 mm with an average thickness 0.5 mm. The cutting wheels and handle have a total mass of 500 grams and a velocity of 1.5 meter per second. And to calculate the kinetic energy, we have to find the volume of the pizza cutter wheel with this formula. And after that, we have to find the mass of the pizza cutter wheel and the total mass with this formula. And then we have to find the moment of the inertia. We use this formula to get the moment of inertia and parallel axis theorem. Okay, and the entry velocity, we have to use this formula to get the answer, and the free body diagram here. So and then last, we can calculate the kinetic energy of rolling wheels with using the equation of a Newton's second law, the rotation equation of Newton's second law. And then we can calculate the kinetic of rolling wheels to get the answer of 6.035 joules. Okay, and that's all.
Hello, my name is MOHAMMAD HAFIZ bin MOHAMMAD NAZRE, and my metric number is CD190134. Today, I would like to present about mini project dynamic, and I would like to present about the discussion of pizza cutter wheel. After the theoretical calculation is calculated, the final result is obtained. Discussion on the calculation and achievement of the objectives shall be discussed by applying the equation that we study for the application in real life. In this study, we have more understanding of the equation and the application of the equation. For the kinematic of rigid body, we use pizza cutter wheel as the application of our project. So, we need to calculate the kinetic energy of a rolling wheel by exciting at a velocity of 1.5 meter per second. Okay, first of all, we need to find the volume of the pizza cutter wheel by using formula V equal to pi r square T. Then, we find the mass of the pizza cutter wheel by using formula M equal PV. Next, we find the moment of inertia of the wheel about its axis of rotation using formula I equal to mr square over 2. After that, we find the mass of handle by the total mass of cutting wheel and handle minus the mass of the pizza cutter wheel. When the moment of inertia of the wheel is negligible compared to the heavy handle for an exit velocity of 1.5 meter per second after crossing a pizza of diameter 0.3 meter, and we can assuming an entry velocity of 0 using v squared minus u squared equal to 2as. After we get all the data, we can calculate kinetic of rolling wheel using a formula K equal to 1 over 2 mv squared plus 1 over 2 Lw squared. We get the value of kinetic energy is 11.66 joule. So, we achieve the objective of our project. Okay, that's all from me. Have a nice day. Thank you.
Hello everyone, my name is Pengkelek. My metric number is CD190239. Today, I would like to present about the mini projects of dynamics. I would like to present the calculations part of this project. For the conclusions of the kinetics of a rigid body. A rigid body is a idolation of a body that does not deform or change shapes. Formally, it is defined as the collections of the particles with the property that the distance between the particles remains unchanged during the course of the motions of the bodies. As conclusions, students were able to calculate, identify and understand the application of kinetic energy used in the pizza cutter wheel, Newton's second laws, and also rotation equation of the Newton's second laws were used in these projects. Besides that, volume of cutter wheels, momentums of inertia, acceleration and kinetic energy were solved in these projects. Besides that, among the experiment and calculations, there are several errors that occur during the experiments. One of the errors that occurs is the value that we get are not very accurate. This may due to the decimal point that we take when taking the readings. Other than that, the readings of a radius of the pizza cutter's wheel is not accurate because of the random errors. This due to the level of the ice when taking the readings. For improvement, students should carefully take the reading and also take 2 to 3 times of the reading to increase the accuracy of the data. In a nutshell, group members have successfully gained experience in how to apply dynamic study in real life. All the aim of this experiment have been achieved by our group members. And I am Punks, and I would like to say thank you for watching.
Hello, my name is SIMRESAN. My matric number is CD190150. So today I'm going to talk about the appendices. Based on our topic, which is kinematic of rigid body. So as similar to the pizza wheel cutter and rocker wheel cutter, we have found the similar applications of those cutters, which is wind turbine and Ferris wheel, and also bicycle wheels. So this is for the appendices we have found, which is similar. So thank you.